Hi guys, you're welcome back to my channel. In this video, I'll be taking you through improper integrals type 2. In our previous lessons, we did improper integrals type 1. So in this section, one asks, what is improper integrals type 2? In the previous lesson, you realized that improper type 1 deals with when any of the limits is infinity, either negative or positive infinity. But for the type 2, we are looking out for f of a or f of b, where we have integral from a to b of f of x dx. This giving us infinity, either plus or minus. So if I give you integral from a to b of any function f of x, where my limits is a to b, they are all finite or they are all normal, like numerical value to know, which are anything other than infinity. But infinity arises when we put in our limits inside, right? So it can be 1 over x, where you are taking from 0 to 1. I realize that when you put 0 here, it becomes what? Undefined. That is arising for the what? Infinity situation. So for type 2, we are interested in when we put in our limit, it results in an infinity situation. Okay, so that is the concept here. So as we did before, assuming I have AB of f of x, right? Dx. And when I put my limit inside, I'll be getting infinity. Assuming that b will be the one causing it, I will simply take limits, right, as an unknown c approaches b. Okay, as an unknown c approaches the b, integral of what? A b f of x x. That's all. Let's get a clear understanding after solving this problem here. So you can see that the problem is saying evaluate from 0 to 1 of 1 over 1 minus x dx. Right. To solve this problem here, what do you have to do? You have to see if it's indeed type 2 improper integral. So when I put 1 as wherever I see x, what do I get? I get 1. When I put 1 here, I'll be getting what? Infinity. I'll be getting infinity. So once I see that when I put any of my one of my limits into it and I'm getting infinity, then this to give me 1 over 1 minus 1, and that is what? 1 over 0, which you don't accept, right? Which you don't accept here. Yeah. So in this case, what I'm going to do is you move straight to using limits. So this our problem here will become limits as x, sorry, limits, so limits as we have our integral. So now to be 0 to what? B. I told you that the variable, the number which is causing the infinity situation will be represented with a variable. So I'll have as b approaches what? 1. Okay, as b approaches what? 1, right? So as b approaches 1, we say that we're going to have, and normally 1 is at the upper limit, we take the left side of it. Okay, the left side of it. So we say that it is left discontinuous. Okay, that it is left discontinuous. So we take limit as b approaches 1 minus this one. Then we bring our f of x. So I simply go ahead and I'm having limits as b approaches 1 of 1 minus, let me bring the minus, of integral 0 to b, and our function is 1 over 1 minus x dx. What is this? Integral of 1 over 1 minus x is the same as natural log of what? X, right? Natural log of what? 1 minus x. Natural log of 1 minus x. Yes. So, but this one here, we can't just straight away, because when you take the derivative, you're not getting 1. So let me go by the normal systematic approach. So let's u be equal to 1 minus x, okay? Then du over x equal to negative 1, right? So then I can say that, let me put all the limits and everything on hold. So when I come to this section, I'll have integral from 0 to b of 1 over u. Then my dx is the same as negative du. So I'll bring my negative du. Okay. So in all, I'll be getting my derivative integral to be negative natural log of what? U plus C. That's all. So I'll bring in my U. So negative natural log of the absolute of what? 1 minus x. One will ask, why did I introduce the absolute? I introduced because natural log doesn't take in negative numbers. Whenever you are dealing with variables in the natural log, you have to cater for the fact that you don't know the value of the variable. So you have to account it using the absolute sign to make whatever the output to be positive. Then we are taking limits as b approaches 1 minus, which is still 1, of this expression. So what do we do? What do we do? So here it was a definite integral 1 to 0, sorry, 0 to 1, meaning that my c will be not negative of natural log 1 minus x. Then I introduce my limit, okay, that is 0 to b, 0 to b. So once I put 0 to b, what will my expression here be? If I put 0 there, you know that when I put b, I'll have what? Let me push it up here. So I'm going to have my limit as b approaches 1 minus here of, so when I put b inside, I'll have negative natural log of absolute of 1 minus b, right? Then let's see, when I put 0 here, I'll be getting what? 1, and you know that ln 1 is 0, so that one we will not focus on that. Then here, what do? We put our negative 1 inside here, and that will give me it's not negative 1, we put our 1, so that will be giving us negative ln 0. So that will be giving us, so for the negative side of 1, we can choose any number close to 1, okay? So when you choose any number close to 1, remember, limit is about the nature of a function as you approach that function certain point. So here we are trying to approach our function negative natural log 1 minus b as you approach 1 on the left side, so minus 1. So on the left side of 1, you can have something like 0.999999. It's right on the left side. So you can take your calculator, punch negative natural log of 1 minus 0.999999, right? And you realize that you'll be getting a positive number, 9.2. So you can make the 9 as many as you want, okay? You can make the 9 as many as you want. So therefore, our limit will give us natural log of absolute 1 minus, taking any value close to 1 on the left side of 1, 0.999999 will result in what? Positive infinity. So as I said, use a calculator. Just be increasing the number of 9s. On the left side of 1, we don't necessarily put 1 inside. Realize that it's only polynomial functions that when you find a limit, it's so easier for you to be doing that substitution. This is because polynomial function is continuous. Once it's continuous, for the functional value will be the same as the limit value. But in transcendental functions like this, we don't just put it in it. Otherwise, there will be discontinuity somewhere. And that will be the end for this section. Thank you for being with me. Please don't forget.